past few days. What are the two methods of graphing?
Solving equations. Graphing.
Yeah. Remember, we have the y equals mx plus b, right? Where b is what?
Cross.
The y-intercept. Yep. And what is m?
Slope.
Exactly. Okay. What's our other method?
y equals ax plus bx.
Nope. You're thinking of ax plus by is equal to c, right?
Yeah.
That's the standard form. Our other method that we have is putting in the points, plugging in the points for the equation. So we have y equals 4x plus 2, so let's plot some points. And hopefully what I'll show you is this y equals mx plus b is a little bit of a faster way to graph. So let's pick x to be 0. Then what are we going to get for y? 2, right? Let's pick x equal to 2. Then what would y be? 10, yep. And then if we pick x equal to -2,
Negative 10.
be -6, wouldn't it? Okay. So then if we go to graph this, we get okay, so we get 0, 2, and you can see that from our y equals mx plus b format, that that's right. So then we get x is 2, and y is going to be 10, it's up there, and then x -2, y -6. So there's our line. And I picked a point here that's going to be, you know, that's going to make our graph pretty big, so maybe you want to pick 1 instead of 2. Okay, so now if we look at the y equals mx plus b type, so we have y equals 4x plus 2. Okay, so help me graph it. What do I start with first?
2.
On the x or the y?
y.
On the line.
On the y, right. Okay. Now what?
It'd be 4 over 1.
And 1 over 1.
Then you go up 4 over 1.
4 over 1, okay, there's a point. And I can go
Down.
down 4,
Over 1.
And over
back 1, right?
Yeah, back 1.
Okay, and if we wanted to put in our 2 points, we could see that 2 and 10 and 2 and -6. Okay, so as you can see, we have 2 different methods of how we can do the same problem. Who did the plugging in the points? Anybody? Or did you all use the y equals mx plus b?
I have a question.
Yeah.
So if like on the y, there is like a number before it, how would you, you first solve for the y?
Okay,
Let's
so
see.
you're saying like
If those
2y is equal to x plus 10? You're saying like that?
yeah, something like that,
Okay. Well, how can we get rid of the 2 in front?
by -2.
Well, what's happening here? What's 2 and y doing? They're multiplying, right? You're multiplying 2 and
Oh,
y?
divide by,
Okay, yeah, you divide. So then you get y is equal to 1/2 x plus 5. Okay, so yep, you start out by getting your x on the other side, and then if there's any coefficient in front of the y, you want to get that out by dividing. Same thing if this was a -2y, you divide by a -2. -2. Okay. So let's go through the problems on your warm-up.
I understand the number.
Alright, so we start out by making our coordinate plane. What's our first equation?
Y equals 2x.
Okay, y equals 2x. Alright, so what's b here?
Nothing, a 0.
0, you're right. There's a b there, it's just 0, so we want to start out at 0, 0. Okay, now what's our slope going to be?
2 over 1.
2 over 1,
Yep.
right?
Yep.
Everybody agree?
Yep.
So then what do I do?
Up to.
Up to over 1.
Up 2 over 1.
Right.
Up 2 again, over 1 again,
Or you can go down 2 over 1.
okay? And then down 2, back 1, you're right.
Yep.
Down 2, back 1. Same thing. Okay, and then you can go through, and there's your line. So if you think about this, I have some points here, but how many points are we actually gonna have?
3?
No.
Yeah, no, a bunch of them.
A bunch of them, right? But what's the math term for that? Infinity, right? Yep. Okay, so if we wanted to plot out some points, if x is 0, what's our y gonna be? X is 1, we're gonna get y is equal to 2. X is 2, y is 4, right? Negative 2. Okay, and so you can see there's 4 points, but on this line, we're gonna have an infinite number of points. Because any value you pick for x, you can get back the value of y. What if we pick x to be 100? What's y gonna be?
200.
200, yeah. Okay, so the next one. What's our equation there?
Y equals 3, 3
3/4 x. Okay, so on this one again, what's our b?
0.
It's 0, right, because there's no constant in the back. I'm not used to working with one of these, can you tell? Okay, so then our slope is,
No, you go up 3 over 4.
slope is 3/4, right? So up 3
over
over 4, up 3 again, over 4, and we can go the opposite way, down 3 over 4. Okay, and there's our line. That's y equals 3/4 x. Any questions? X and y, alright, our equation.
It's negative, y equals negative 3x plus 1.
Y equals 3x plus 1.
No, y equals negative 3x. No negative y.
Alright. Brady, what's our b gonna be? What's our y-intercept? 1.
So
Slope,
3 over 1.
okay, it's gonna be negative 3 over 1, right?
Oh,
Negative
I
3x.
don't see the negative there. I mean,
Right, so down 1, 2, 3,
down 3 over.
over 1, yep. And then when we go up this time, we wanna go back 1. Because it's negative 3, so our line is gonna be negative. It's gonna go down from left to right. We can go up 3 again, back 1. 3, 4. just y equals negative 3x plus 1. Okay, so these last three are a little different. We have x plus y is equal to 1, and that's not in our y equals mx plus b form, is it? Okay, so what do we need to do to get it to y equals mx plus b?
Minus,
Well, the x and
Yep.
the,
What's that? Yep, exactly. Subtract x by both sides. So we can get y is equal to
1
1 minus x.
1 minus x, or negative x plus 1, okay? Okay, so now we have it in the y equals mx plus b form,
We start at 1,
right? Of 1.
and then,
it'd be negative 1 over 1.
go
Yep.
down 1.
Exactly, because we don't write it, but there's a negative 1 in front of that x, and so you have it as negative 1 over 1. So we go down 1 and over 1.
Over, yeah. When it's a negative, you can go on the other side, you go on the positive side.
When it's a negative, you go down and over. When it's positive, you go up and over.
Down.
So,
Here's Chris, here's why. Because what is slope?
Slope, is it how, it's,
What is slope?
let's begin.
Rise over run, right?
Yeah.
So if I have a rise of a negative, so if I have a negative slope, that's telling me I have to go down, and because I'm dividing, right?
Yep.
Negative divided by a positive,
Negative?
so that's gonna give me my negative.
Oh.
And if I go up and back, that's a positive divided by a negative. Positive divided by negative, still negative, isn't it?
Yep.
so if we were to graph it, here's gonna be your positive slope,
Then negative slope.
and your negative slope is gonna be like that, just general lines. Okay. So back to our problem here, we have down 1 over 1, and then up 1
Over 1.
and back 1, right?
About 1.
Up 1, back 1, up 1, back 1, up 1 over 1. Okay. So as you can see, this is a lot faster than plotting the points in and picking different points for x. Any questions?
If we knew this like on the beginning of the year,
Huh?
if we knew how to do this method at the beginning of the year.
Back at the beginning of the year.
Huh?
We did this at the beginning of the year.
No, like we didn't plug in the points like we
No,
had
we
to
did that
solve.
too.
We had to solve. Didn't we? Oh, I got memory.
Not. Not. It's the exact same thing we did back then.
Only thing we didn't do was like these equations that weren't in my form. And it should be better.
Okay, so we have to do some work to this one to get it into y equals mx plus b form. So, Emily, what do we have to do? What's the first thing we should do? Yep, add 6x to both sides. Or 6x plus 4. Okay. And then this is just like the question you asked earlier about the coefficient in front of the y. So now what should we do? by 2, and
Yeah.
then I'll get y by itself, right? Okay, so I'm gonna rewrite this as y equals 3x plus 2. That way it's in our y equals mx plus b form. Writing it the other way is fine too, but it's easier to see this way, okay? So now we're back to just what we've been working on before, right? So we want to go up 2, and that's our y-intercept. Now what? Back. And there's our line. Okay, so for this last one, let's do this twice. We'll pick the points for it first, and then we'll use our y equals mx plus b form the second time.
We have to solve that.
What's that?
Do you have to solve like to try to put in the y mx plus b denominator?
You can. You can. That would be a lot easier, because then when you put in your point for x, then you already have y equals to that number, right? Instead of putting it in here and then having to do a bunch of math to get to that point. Okay, so let's go ahead and get it in our y equals mx plus b form first. So what do you think? You can subtract the 2x, right? Okay, maybe try to do that from both sides. Okay, that gives us 3y is equal to minus 2x minus 12. Okay, and then we got that 3 in front of the y, so we gotta get rid of that. Yeah, divide by 3. Y is equal to negative 2/3 minus 12 divided by 3. Minus 4, right? Okay, so we've got that point now, so what if we pick x to be equal to 0, 1, and negative 1. Okay, so if we pick x to be 0, what's y equal?
The negative one.
Negative 4, yeah.
I'll just my negative four.
Okay, so I substituted the 0 in for x here. Negative 2/3 times 0 is going to be 0, right? And then this is minus 4. Okay, so then if we put in, stretch these, 2, 3, and negative 3. Because then if you think about it, when we multiply by x, we're going to get rid of that fraction, aren't we? So what about 3? 2/3, negative 2/3 times 3, the negative 2, right? And then minus 4,
Negative 6.
negative 6. Okay, and then if we choose negative 3, then we have negative 2/3 times negative 3,
Should be a positive
positive 2, yep, minus 4,
2. The negative 2 is
negative 2. Okay, so there, we've got our points. You can plot those. 0, negative 4, 3, negative 6, negative 3, negative 2. Okay, so that takes some time. Now, if we use our y equals mx plus b form, we go to minus 4, right? And then we can go down 2 over 3, up 2, back 3, up 2, back 3, down 2 over 3. And there, I've already found more points and graphed my line in just that little bit of time. So does anybody have any questions off of the warm-up? Okay, good. So now if we look at solving systems by graphing, what if we have, in this example here, we have y is equal to x minus 1 and y is equal to negative x plus 3, okay? So y is equal to x minus 1 and negative x plus 3. So this is just the same thing as what we've been doing, but now we have two equations we have to graph on the same coordinate plane. Okay, so we can go minus 1, up 1 over 1, up 1 over 1. And we want to make sure that this line and our points are plenty long enough because we're not exactly sure where this one's going, where this other line is going to intersect, if it is even going to intersect it. Okay, so there's our y equals x minus 1 line. And now we have y equals negative x plus 3. So we know that our y-intercept is 3. And what's our slope going to be?
Minus 1, 1,
Down,
3
down 1.
over 1.
over 1, right? Down 1 over 1. Okay, and since we graphed our other equation first, we don't have to make quite as many points. Now you can see there's your line. So if you remember when we were just graphing this one equation, we had an infinite number of solutions, right? Now how many solutions do we have? Just one, right here. At what point is that?
2, 1.
2, 1, exactly. So that is our one solution, because as these lines keep going further and further, they're never going to touch again, are they? So this is the same thing, kind of what you've been working on, and you'll start working on this on Monday. But it's, like I said, it's pretty much the same thing as what you've been doing, other than you just have to graph another equation and see how many solutions it has. Okay, so we want to try our example number 2 there. Alright. Drawing out the line. Okay, can I have a volunteer to come up and try this one?